Hello student and welcome back for 3D printing application in various industry lecture series. I am Sagar Dhotre or welcome all of you for this lecture series. Uh, in previous lectures we have already seen applications like toy industry, shipbuilding, coin industry, automotive industry and defense industry. Today we will see more four industries: construction, food, furniture. Okay, so one by one we will see uh, UAV, furniture, construction and food industry. As we know that the rapid prototyping technology begins in 1980s, uh, and today in 21st century it's a fundamentally uh, transforming technology or emerging technology, which is most revolutionary technology in this century. This is additive manufacturing, which can transform uh, what we have to design. We can manufacture prototype and we can go for manufacturing for mass production. So that can be do with this 3D printing. So in this lecture or presentation we will discuss the impact of 3D printing technology in these four critical industries, that is unmanned aerial vehicles, furniture design, manufacturing, then construction and food production. So the historical evaluation in 3D printing across the different industries. In 1980, first time the 3D printing has been introduced. Then that's called as a primary rapid prototyping tool to manufacture layer by layer additive manufacturing principle. Early of 20s, it expands its horizon. The furniture in designers experiments with the 3D printed joints and decorative elements, while Kularni inventors explores the printing sugar sculptures and chocolate decorations. Material science advances introducing new polymers and composites, broadening the application possibilities significantly. In 2010, mainstream adoption has been done. In this decade, the explosive growth uh, across the multiple sectors has been done. Constructing companies begin the printing architectural components and even entire structure with the help of 3D printing machine. Uh, UAV manufacturer discovers the 3D printing is the most potential method to produce lightweight and complex aerospace parts. The patent experiential decorated by the technology make it accessible to the small business and hobbies, spurring innovation. In recent year, the intelligent and integration with respect to 3D printing with the artificial intelligence for design optimization, bioprinting for food application using alternative proteins and sustainable materials for recycled sources. The technology has matured from experimental to mission critical, supportive supply chain, enabling the mass customization and addressing this sustainable technology challenges across the industries worldwide. Um, the main role of the 3D printing in UAV, which is lightweight innovation for flight. Now, critical role of aerospace is to develop the aerodynamical shape in the traditional manufacturing. The 3D printing revolution enhance the uh, this manufacturing process, that is lightweight component that traditionally machine cannot be achieved. The advanced material like carbon fiber reinforced nylon, titanium alloys, and the aerospace grade polymers, which enables the creation of complex internal geometries, lattice structure, and optimize the weight to strength ratio essential for flight performance. The key advantage with doing this is this: we can reduce the weight by 40 to 60% as compared to the traditional parts, which can be improve the fuel efficiency and extend the flight duration. Rapid prototyping accelerates the development cycle from months to days or within hours also, based on the component size and quantity. On demand part replacement in a remote and compact zone can be possible with the help of this 3D printing. Design optimization through generative algorithms can do uh, for more for huh. Then consolidation of multiple components into single print, that is a small assembly you can directly print in a single component. We have an example regarding this. In a GE Aviation GE9X engine, the GE Aviation revolutes GE9X engine, the world's most powerful company, commercial aircraft engine. Uh, Incorporates over 300 3D printed components, demonstrate their aerospace grade precise and reliability. The fuel nozzle, previously assembled from 20 spare parts, are now directly printed with a single piece, reduce the total weight by 25% while increasing the durability by 500%. This is the breakthrough showcase how the additive manufacturing enables the complex cooling chamber, optimized airflow geometries, and consolidated assemblies impossible through conventional manufacturing. The technology has reduced the production cost by 30% and improves performance metrics, setting new industrial standards for aerospace aviation. With respect to this advantages, we have few limitations and challenges also, as the material cost is very high for aerospace grade polymers, which is about 200 to 500 euros per kg. Specialized technical expert required for design and post processing. Production speed limitation is there, so we cannot go for mass production. Uh, Stringent certification required for aviation application. Quality control and consistency is one of the challenge which we know that the 3D printing mm, can be uh, overcome in future. The next application is a furniture application where the design freedom meets with the strength, structural strength. The basically when we design a particular furniture, the parametric design revolution has been done with the help of 3D printing, because 3D printing empowers the furniture designer to create a parametrically generated forms that responds to ergonomic data, aesthetic performance, and structural requirement. The complex organic shapes, biometric patterns, and customized dimension becomes achievable without expensive models or any excessive tooling. Then innovative joinery system. The printed connectors and joints eliminate the traditional fasteners, creating seamless assemblies with interlocking systems mechanisms. These components can improve the complex geometry like span fits, threads, interlocking features that enhance the both aesthetic as well as structural performance. Then sustainable production. Um these manufacturing, that is 3D printing or additive manufacturing, drastically reduces the material waste compared with the subtractive method or a traditional method. PLA and recycled polymers enable the eco-friendly furniture production, while on-demand manufacturing eliminates the overproduction and excessive inventory, aligning with the circular economy principle. The major advantages is that the we can designer can interpret the interpret the concept in a days rather than weeks or months. Mass customization, each piece can be tailored or individually customized specifically without retooling. Then waste reduction, the total mass waste reduction is up to 90 to 95% as compared with the traditional. Then a lightweight structure, as the material used or infill patterns and lattice design create strong but lightweight furniture components. We can manufacture complex geometry, that is organic curves, honeycomb structure, then topology optimized forms enhanced with the both function and aesthetic looks. You can see in the right side diagram. In University of Forest exam conducted the uh, performance test in between traditional manufactured furniture and 3D printed manufactured furniture, and they have found out that the 3D printed manufactured furniture uh, gives the superior stiffness values and load bearing capacity with the proper design. The study also tested in various joint configuration under stress, finding the 3D printed joints with optimized geometry over for over outperformed conventional metal brackets in several metrics, particularly in distributed load scenarios. This validated the 3D printers printing as a viable method for creating structural furniture components. There are few limitations, that material strength remaining below the solid or wood or high quality plywood. The layer adhesive can be break or weak points under the stress. Production scale is limited by print bed size and speed. The surface finish often required post processing for commercial quality. Now the 3D printing utilization in construction area, that is building the future layer by layer. In the construction industry, some we generally use bricks to manufacture houses or make a construction. In this, we need a huge amount of time to build this construction, and some architecturally or you can say uneven shapes or complex shapes we are not able to manufacture with the help of the simple construction method, but with the help of 3D printing, we can accept this challenge, and we can able to construct the complex geometry shapes in with the help of 3D printing in construction. What kind of architectural freedom and complexity advantages provided by 3D printing? The 3D printing liberates the architects from the construction from traditional construction method. Constant, the whatever the constants is provided by traditional construction methods. The complex curves, organic organic forms, intricate facet, optimizer, load bearing structures become economically feasible with the help of this 3D printing. The concrete extrusion system can be print double curved walls, integrated utilize channels and decorative elements in a single continuous operation, which eliminates the framework cost. On-site and on-demand production. Uh, the 3D printers are mobile, so we can directly put it to construction site and produce a component, or either construct from digital model to direct at to feasible model. This approach eliminates the transportation cost, which reduce the supply chain independencies, enable the rapid response to the change in site condition. Digital fabrication allows real-time design adjustment without expensive change in order. Now, sustainability of material innovation. Construction of 3D printing utilize the innovation material formulates, including recycle, re-aggregate, geopolymers, fiber reinforcement, composites, and even earth mix based mixtures. These material offers demonstrate the improved thermal performance, reduce the carbon footprint, and enhance the durability compared with the conventional concrete while generating the minimum waste. Now, advantages we have already discussed that construction speed we can increase with the help of these directly manufactured 3D printed houses. We reduces the wastage by 90 to 95%. Then labor efficiency, we can reduce the on-site workforce required, address the skill labor shortages. Cost saving, we can able to save 30 to 60% cost in construction for building type based on the building type. Design optimization, topology optimization creates a structure using minimum material with the maximum strength. Then disaster response, rapid deployment of emergency houses in crisis zone can be done. uh, we have a simple one case study where the emergency house solution is provided with the help of this 3D printing application. In right side you can see uh, in figure number A, the 3D model has been developed. In figure number B, the first 3D model has been developed, and in third C, uh, the manufacturing process has been started, and D is the final outcome of the house. The multiple organization having deployed the 3D printing emergency house following the natural disaster and for refugee population. Icon's collaboration with the new story created 3D printed homes in Mexico in under 24 hours each, providing dignified, resilient housing for vulnerable communities. These structures withstand seismic activities, extreme temperature, and high wind, while the costing less than 50% traditional as compared with the traditional construction. The technology enables the rapid scaling to address housing crisis, and the printers operating around the clock to produce multiple units simultaneously. Uh, there are few challenges we need to identify. We have to, while designing building, there is a building and safety codes, which is uh, which is still having some lagging with respect to 3D printing material manufactured houses. Nowadays, the quality of material get improved, and uh, they are able to justify these building codes and safety standards. Scale and speed limitation, in current system printing speed will be 3 to 30, 5 to 30 centimeter per second, making large construction time intensive. Multiple story buildings required printer repositioning, and so especially repositioning every time. Weather conditions affects the outdoor printing operation, limiting deployment and flexibility of the printer. Then most important barrier is initial investment. The industrial scale construction printers cost 2 lakh to 10 lakh year dollar, which which representing the significant capital expenditure. The material required, specialized formulation and testing, so workforce training and digital modeling expert add on to the implementation cost will be occurred. Now, last one is the food industry. The food industry application of 3D printing in food industry, personalized nutrition and culinary creativity. In 3D printing represents one of the most innovative and unexpected application of additive manufacturing technology. Uh, no one has thought about this also. By extruding edible materials layer by layer, this technology enables unprecedented control over the food structure, composition, texture, and nutritional content. From the food printing is reshaping how we can conceptualization food production and consumption. The technology addresses the multiple contemporary challenges that food waste reduction through the precise uh, partition, neutral customization, uh, nutrition customization for health condition, sustainable protein integration, and creative gastronomy that was previously impossible to achieve manually. So in figure you can see the 3D printed cookies, 3D printed foods can be manufactured. With the 3D printed, we can personalize our nutrition. Now, 3D printing enables the precision control over the macronutrient ratios, vitamin content, vit- vitamin content, and the caloric caloric density. The medical application including dysphogia friendly meals with an normal appearance for soft texture, diabetic optimized desserts with controlled sugar release, and allergy allergen free customized meal. Nutritionists can design meal targeting the individual metabolic needs, age related requirements, and ath- athletic performance goals. The most important example or case study is the NASA has implementing this 3D printing food 3D printing technology in their space craft, or you can say space mission. So NASA partnered with the System and Material Research Corporation and BHAX to develop a 3D printed pizza for long duration space mission. This system provides donuts, tomato sauce, protein layer subsequently, then cook and assembled pizza. This breakthrough addresses the critical challenges extended shelf uh, life through powder ingredient, nutritional customization for individual astronaut what they have need, reduced packaging wastages, psychological benefits for familiar appetizing food during isolation. The technology proves additive manufacturing viability for extreme environment and closed loop food system. So basically, there is again few limitations and challenges will be there. The cooking constraint: the most printers cannot cook food, require separate heating. That is, additional heating will be needed. Then speed issues there. The printer remains slow. They can work for 5 to 15 minutes per serving. Component compared with the conventional preparation. Material restriction: the work best with the purees and pests. Whole ingredient challenges will be there. Cost barrier: initial equipment cost will be €1,000 dollar to $50,000, and specialized ingredient remain more expensive. Technical complexity: the required food science knowledge for receive formulation and equipment maintenance is mandatory. So there are huge challenges still uh, the food industry is facing while implementing the 3D printing in food industry. Now all across these four industries, what are the advantages we can find out? The unpredicted design we can do, that is a complex shape we can do with the help of 3D printing. Material efficiency and sustainability. We can utilize the more sustainable material. We can reduce the carbon footprint. We can use biomass polymers for future to reduce the carbon footprinting, and also we recycling issues. uh, we increase the sustainability of that material, and with the help of this we can increase the material efficiency also. On demand and distributed manufacturing, as the required as you required you can manufacture it within a few hours. So on demand we can do manufacture anywhere. Distributed manufacturing is nearby the customer location, so that the transportation cost will be reduced, and the rapid response will be given to the market demand. Mass customization capabilities, we can customize multiple time or multiple s- parameters or with the help of different specifications, but we cannot produce mass production with this help of 3D printing. Then rapid prototyping, as we know that the faster to time to make the new product, more expensive testing for design variation, reduce the development cost through early failure detection, enhance the collaboration with the physical prototype, risk reduction by validating concept before major investment, then supply chain transformation, as we can use distributed manufacturing, we can reduce the inventory optimization cost, also reduce the dependency on supplier or network. Some limitations and challenges with respect to these four industries. First of all, the important thing is a minimum capital investment barrier is there. For entry level, you have to spend 5,000 euros minimum, and for specialization or food type of printers, we need 30,000 euros, 3 lakh euros minimum, maximum investment. So this is a only a printer investment there. Another facilities is needed for post processing, material handling system, maintenance the infrastructure. Small to medium enterprises cannot be justify this investment, so they are not interesting uh, for adopting 3D printing technology in their manufacturing concept. Constant material cost and availability, there is a special material has been manufactured and which possesses to 5 to 20% more cost as compared with the conventional manufacturing materials. Aerospace grade polymers can be for 3D printing requires 200 to 500 kg, versus in traditional the material cost is 5 to 10 dollar per kg. So similarly, in each industry having that variation, you can see technical expertise required. Yes, to successful 3D printing implementation, the multidisciplinary knowledge is required. The 3D software, uh, CAD software, and computational design principle must be known. Then material science and processing parameters must be, the person should have that knowledge also. Then machine operation, calibration, and troubleshooting with related to 3D printing must be able to identify. Post processing techniques and quality control should be well known with that person. Design for additive manufacturing principles should be followed by this expert person. So these kind of expertise is needed while operating this 3D printing technology and the components. Uh, Then production speed is very less. So for prototyping, it is very pro use. We can use the 3D printing, but mass production it is quite difficult to produce uh, components in a mass production or service in mass production as compared with the traditional method. Then quality and consistency challenges. As we know that the quality has been modified dependent on various aspects, even though environmental temperature, then number of hours the machine is working, material grade, etc., etc., etc. So based on that, the layer adhesion, surface finish, dimensional accuracy, mechanical properties, corrosion issues, and reproducibility is the major challenges. Quality related challenges can be occurred. Regulation and standard gap is there because no one has pro generated, or you can say a rule book is developed for 3D printing components, and certification courses certification is necessary for using the 3D printed component in different applications. So future lookout, in future what we can integrate with the 3D printing. There are three aspects where we can mostly focus in future. That is AI driven design optimization with respect to 3D printing. Then IoT enabled smart manufacturing with the respect to with 3D printing, and sustainable material revolution with the help of 3D printing. Emerging applications which can be corporate, that is biomedical breakthroughs, space manufacturing, disaster response system, and 4D printing evolution. Economic and social transformation can we do with the help of distributed manufacturing, networking, make mover empowerment, educational integration with the 3D printing fundamentals, development developing the world, leaf frogging, circular economy enables and customize the manufacturing standard for 3D printing. In flow, in future lookout, we are expecting from 2025 to 27 the regulatory framework matures with the AI design tool becomes mainstream, multi-material printing, standardization, construction, 3D printers scalable will be commercialized. In 2028 to 30, we are expecting the bioprinted food reaches to the supermarket, and sustainable material dominates the feedstocks. Distributed manufacturing network established the globally, and speed will be increased by 10% or 10 times. In 2031 to 35, we are expecting that bioprinted organs achieved clinical approval, space based manufacturing operational, 4D printing enters commercially in application, and fully automated design to production flow work will be developed. So these are the future aspects with respect to 3D printing. I hope you have understood the utilization or application of 3D printing in these four industrial applications. Uh, if you have any doubt, you can personally contact me. Thank you. Thank you very much for attending this lecture.